Okay, this is statistics, summarizing, representing, and interpreting data. Standard 6, subpart C. Today we're going to be fitting a linear function for a scatter plot and having it suggest a linear association. All right, here are a few terms to know. Jot these down in your journals. Okay, a scatter plot is a graph used to determine whether there is a relationship between paired data. Scatter plots show trends in data. So what they mean by paired data, those are all of your coordinate pairs, all your ordered pairs. And we're going to be putting a bunch of those on a graph, and we're going to see whether or not they have some type of relationship to each other, or whether or not they're just a bunch of ordered pairs that are put on a graph, and they have no relationship. So the first one you see here, if I were to take away the line and just look at all of the ordered pairs, all of your X, Ys, we see a pattern going from the lower left to the upper right. And if you were to just picture that as a line, you would see that it has what we call a positive correlation. So what it says in the box up here, if Y, all your Y values tend to increase as X increases, then the paired data are said to have a positive correlation. Or in other words, we have a positive slope to this line. And as you can see, all of these points, as we tend to go to the right, as we increase our values in X, our Y values are also increasing. So as we're going to the right, we're going up. As we're going to the right, we're increasing. We are going up with our values, which means we're rising. So we have this positive correlation. All right, now the converse to that, again, if I were to take away this line, we see all of our ordered pairs. And as our x's are increasing, we are going to the right, it appears as though our y values, our y-axis, all of our points are going in this downward fashion. So if I'm at -3 and I move to the right, it looks like our values are dropping. And we call this a negative correlation. And we're going to get more into some examples in class that might relate to these positive and negative correlations. All right, the third type of correlation, we call this having no correlation or relatively no correlation. And as you can see here, I didn't put a line because I can't tell whether or not it's positive or negative. They just happen to be a bunch of random ordered pairs that are put on a graph. So there is no relationship here. Notice that's important. In the word correlation is relation, and we don't have any relationship among these points. Excuse me. Okay, now it says make a scatter plot of the data in the table. Describe the correlation of the data, draw a line of fit, and then the most difficult part is then to write an equation of that particular line. So we have a bunch of random numbers here in our table, and our job first is to make a scatter plot. And that basically means let's take all of these ordered pairs, x, y, and put them on a graph. All right, now I know that this table eventually is going to be in our way, so I'm going to have to get rid of it soon. But let's plot as many points as we can using the table in front of us here. So our first ordered pair says x1 and the output y is 10. So if I were to go to 1, 10, I'd put a point. The next one is also 1, 12. So we go 1, 12. Well, if this is 10 and this is 30, we know that this is 20. So then this has to be 15 right in the middle. So we're going to go right above it. You know what? Let's get these dots to be the same size. That's going to be an issue. So let's get them all to be that size. So 110 and then 112. It's right about there. All right, 333. 3. This is 30. This is 40. This is 35. It's about 33. 446. 3, 4, 40, 50. Right about there. 559. 50, 60. Right about there. 670. See here. Right on the line. And then we have 9 and 102. So let's say goodbye to, let's just move it down here, I guess. Our last one was what, 9, 102. There's 90, there's 100, 102. All right, so now let's go back. We plotted our points. It says now that we've plotted our points, let's describe the correlation of the data. So what they mean by a description is, do we have a positive, negative, or no correlation? All right, so this is said to have a positive correlation. So we know that as our X values are increasing, our Y values are also increasing. So that is positive. Okay, so what's next? Draw a line of fit. Okay, so this is an estimation skill that we're going to be using. We're going to take out a ruler or a straight edge. And the rule of thumb when you're drawing a line of fit is that you want to try to get as many points on the line as possible. And if you can't get them all on your line, try to get them as close as you can with equal amounts of points on each side of the line. So let's just start by drawing a line here. Yeah, let's use red here. Okay. And I'm just going to take a random line and draw it, I don't know, somewhere through the origin here. And let's play around with that line here. Wow, that actually wasn't too bad to begin with here. All right, so again, we want to hit as many points on the line as possible, and if we can't hit them all, we'll try to get the same amount on each side. So let's move it up a little bit. I got what, 1, 2, 3, like 4 touching the line, but the remaining 3 are all on the right side. So I'm going to do a little tilt here. So let's tilt it a little bit. And did I make it worse? Okay. All right. I think that that is going to be pretty good for us right there. All right. Now, we have what we call a line of fit. Sometimes we call it the best fitting line. And now that we have a judgment on where the line belongs, we can do the last part of this that says, let's write an equation of the line. Now we've been doing a lot of writing equations of the line. We've been using our slope-intercept form, y equals mx plus b. So in order for us to determine our slope and our y-intercept, we could use a couple of different methods. If I were to just look at the graph, I can find my b, which is kind of why I came through the y-axis here, just so I can kind of see. It looks like it's a little bit more than 0, and definitely less than 5. So I'm going to say it's somewhere between 0 and 1 on this one. So let's go y is equal to mx plus b. And I know that b is a little bit more than 0, so we can use fractions. Let's just go with about 1/3 here. Again, I used my estimation skills, and you are going to have answers among your classmates that are going to differ a little bit. They can't differ too much, but they will differ definitely when it comes to talking about fractions. All right, now the slope, we've learned that we can take any 2 points on the line and use our slope formula to determine. And you know, I'm going to pick some points that are pretty comparable to each other. If you look at the numbers, I see that 1 and 10 and 1 and 12, I mean, they're almost the same point. So I'm not going to use them to determine the slope. So why don't I venture down here to maybe using the point 112. What does this one look like? It's about, I don't know, a few away there, 59. So they're all pretty clustered together here, 12 to 33. The difference between those two, the difference between 33 and 46, the difference between 46 and 59, they're all comparable to each other. So I'm just going to take one a little bit down the road here. And I'm going to use my slope formula to determine the approximate slope. So let's take the difference in our y values, 59 subtracted by 12, and we're going to take the difference of our x values, which is 5 and 1, and let's see what we get here. So 59 take away 12 is 47. 47 divided by 4. Well, that's a little less than what? So 4 goes into 48 12 times, so it's a little less than 12. So I'm going to estimate that. Again, it's my job to do my estimating, so I'm going to say it's about 11, I don't know, 0.8, 11 and 8/10 x plus 1/3. And let's just check another point just to make sure. So is it going to be the same, right around 12? So I'll get rid of this one, and let's just check the 670. All right, so the difference of your y's, 70, take away 12 over 6, take away 1. So we have 58 over 5, and we know that 5 goes into 60 12 times, and 58 is a little smaller than 60, so it's going to be a little less than 12. And again, we have the same approximate slope, and I came up with 11 and 8/10. Okay, so we've answered all the questions. We plotted the points. We drew the line of fit. We did some tinkering with the line of fit. We figured out our B, and if you can't see the B, you could always take one of these ordered pairs and plug it into this equation right here using your slope, using the ordered pair that you chose, and then it'll spit out your B. You can do it that way, or I eyed it, and we determined that this is a, if we're describing it, this is a positive correlation. And we have our equation of the line. Okay, in your journals, I'd like you to define those words, write a few sentences on what you learned from this video, and in class, we're going to go over a number of examples. We're going to talk about how these points relate, some real life examples of what you might come across in terms of positive and negative correlations. And we're going to make some predictions on these best fitting lines. We're going to see what the trends are. when talking about these relationships of the points. Okay, I'll see you in class.